In the last video, I talked about the theory behind why unplanned markets should do a good job of finding equilibrium. That is, finding a price at which buyers want to buy as many units as sellers want to sell, and all of the available gains from trade are captured by the buyers and sellers in that market. In this video, I want to talk about some of the empirical evidence that markets actually behave this way when they're unplanned. So the first piece of evidence that I'll talk about is experimental evidence. Your textbook talks about this in chapter 3. They mention a man named Vernon Smith, who, by the way, is at Chapman University. He's on our faculty here, and he won the Nobel Prize in Economics in 2002 for his work in experimental economics. And one of the first experiments that he did, it had the following format. Okay, what you do is you take a group of people, you split them usually 50-50. You tell half of them you're going to be buyers in this market. You tell the other half you will be sellers in this market. And the buyers, you give them a sheet of paper like the following that says you could buy up to, in this case, 4 units. Okay, now for every unit that you purchase, you have a value for that unit. And you earn profit in the experiment by purchasing units at a price that is below your value. All right, so for example, this person has a value of $25 for their first unit. Let's say that they purchased that unit at a price of $15 from a seller. That would give them a profit of $10. Second unit, they have a value of $17.50. Suppose that they paid a price of $12 for that unit. On that second unit, they would have earned a profit of $5.50. Now, their third unit, you can see, is a value of $17. And let's say that after purchasing their second unit, they can't find a seller who will sell to them at a price below $17, a price at which they could make profit on their third unit. So this buyer stops buying after they've purchased 2 units. Well, in that case, their profit would be the $10 on the first unit plus the $5.50 on the second unit, which is $15.50. And the experimenter incentivizes the buyer to actually make these decisions, take these decisions seriously by telling him, look, whatever profit you earn in the experiment, I will pay you that amount of money at the end of the experiment. So that $15.50 is not theoretical, it's actual money that the participant in the experiment would earn. Okay? So these buyers have an incentive to try to buy at a price as low as they can get. Then for the sellers, you give them a sheet of paper, and instead of having values on it, it has costs. What is your cost of producing each unit? Now, the profit that a seller earns is equal to the price at which they are able to sell the unit minus the cost of production. And they only incur that cost of production if they actually sell it, if they produce it for sale. So any units that are unsold don't cost the seller anything. So let's suppose that this seller, on their first unit, they're able to sell for a price of $20. Their cost was $9.50, and so this seller would earn $10.50 on the first trade. Let's say that she manages to sell her second unit at a price of $18. Her cost was $17. That's a profit of $1. And now let's suppose that after selling that second unit, the seller cannot find a buyer who will pay her at least $17.50 for her third unit, and so she stops selling at that point. Then her profit would be the $10.50 plus the $1, which is $11.50. Just like with the buyer, you tell this seller, look, all the money that you earn in this experiment, I will actually pay you. Okay, so she would actually be paid $11.50 once the experiment is over. Now, I'm not going to go into the trading rules for a double auction experiment, but basically it's a lot like the New York Stock Exchange. If you've seen old movies where they used to have people on the New York Stock Exchange floor calling out prices to each other, it's a lot like that, except it's coordinated with an auctioneer kind of matching buyers and sellers together. Okay. Now, I have run this experiment in my classes, and if we were in class together in large enough groups, I would run a double auction with you. But unfortunately, due to COVID, I can't take you through it, but I can show you the results of some earlier experiments. So this is from, I believe, 2 years ago, a class that I was teaching. All right, remember those buyer values? Well, those buyer values are all points along a demand curve. And if you take all of the buyer's values and you rank them from the highest value to the lowest value, regardless of who the buyer is, you get that demand curve, that blue demand curve that shows up on the screen there. Now, you'll notice that this blue demand curve is kind of a stair-step function, and that's because these buyers could only buy in discrete units, one unit at a time. They couldn't sell fractions of a unit. So it's not a perfectly smooth curve. It is a stair-step function, but it still works for our purposes. So take the values, rank them, and you get that demand curve, that blue curve. If you took the seller's costs off of all of their sheets of paper, and then you ranked them from lowest to highest, you would get that red supply curve that shows up on the screen in front of you, which again is a stair-step function. Okay, where those two curves cross each other is the equilibrium for this market experiment. And you can see that that equilibrium is at a price of anywhere between $17 and $17.50 is the equilibrium price. The reason why you can have multiple equilibrium prices here is because of the stair-step nature of the supply and demand curve, okay? But anywhere in that 50-cent range, that's the equilibrium price. And if every unit traded at that price, you would expect there to be 16 units traded. That's the equilibrium quantity, okay? So in the very first round of trading, how did my students do? Okay, what prices did they trade at? Well, we can list those out or sort of print them out across the screen. And that black line that you see there, that is the history of contract prices. And what you can see is that in the first round, the prices started below equilibrium, and then over time they increased and got closer and closer to equilibrium. All right, so obviously the buyers and sellers didn't know what the correct price was at the beginning of the experiment. They had to try to find it. But you see that at the end of the first round, they had found the equilibrium price. That last unit traded at a price of $17.50. And almost every single trade occurred within the supply and demand curves. None of the prices were above the demand curve. Only one price was below the supply curve. Okay, and you can also see that they did, in fact, trade 16 units, the equilibrium quantity. Their efficiency, that is what percent of the gains from trade did they capture. They didn't quite get 100% efficiency. They were only 94.14% efficient. The reason for that is one of the buyers bought one unit that he shouldn't have, and that crowded out a different buyer. So there was a little bit of disruption in this market. But they captured the overwhelming majority of the gains from trade. They did converge towards that equilibrium price, and they found the equilibrium quantity of 16 units, and this was on their first try, the very first market that I ran with them. After this, I ran them through a second market, leaving the supply and demand curves the same. I basically took the values and the costs, and I shuffled them back to different people, but the demand curve and the supply curve were still the same in the second round as they were in the first. In the second round, that is the series of prices at which buyers traded. And what you can see is now, by about the sixth trade, almost every single trade is right there at the equilibrium. Generally on the low side of equilibrium, but still consistent with the equilibrium. You'll see, once again, they traded 16 units, the exact equilibrium quantity. And in the second round, efficiency was 100%. Okay, everybody who should have traded did, and nobody who shouldn't have traded did trade. Okay, so just 2 rounds, and this market has basically found equilibrium and extracted all of the available gains from trade. So this is an actual real-world example where we know the supply and demand curve, we know what to predict, and economic theory does a pretty darn good job of predicting the outcome. Outside of the classroom, outside of laboratory experimental conditions like this, you can also see markets at work with just a simple thought experiment. Most of the people watching this video probably like to eat Mexican food. We live in Southern California. Mexican food is practically a state cuisine around here, and for some people, it's almost a religion, right? It's practically a religious experiment on the order of eating it in and out. All right, so Southern Californians, we love our Mexican food. Now, if you sit and think about it, how many times have you gone into a Mexican restaurant and they tell you, we're all out of food, we don't have anything to sell you? Okay, that's probably not happened. In fact, it's probably pretty rare that you show up and you order a particular item off the menu and they say, sorry, we don't have any of that today. It happens occasionally, but it's quite rare. Okay, so they usually have as much food as you want to buy at the price that they're selling it at. And what's more is, if you sit and think about it, think about the last time you got a call from a Mexican food restaurant asking you, hey, how many chalupas are you planning to eat this week? How many burritos do you want to buy in the next month, right? When has that happened? Well, the answer is never, right? The restaurants never contact you to find out how much you want to purchase from them. They don't do any surveys like that. You very rarely are going to call ahead and order unless it's just for takeout, but you never call ahead and just ask, hey, do you have food today? The answer is always yes. So you have no communication with these folks, but when you show up, they have what you want to purchase, and they have as much of it as you want to buy on a typical day, okay? Why is that? Well, it's because markets do a pretty good job of finding the right price where sellers want to sell as many units as the buyers want to buy. And what's true of Mexican food is true of most every item that you can think of, right? Gas at the gas station, shoes at the mall, computers, smartphones, pretty much all of that. We have about as much as we want to buy at given prices at any given time. Recently, and I mentioned this in another video, recently there's been some disruptions around that, especially most famously around toilet paper, because there's been disruptions to our supply chains from COVID-19, but also because prices have not been allowed to adjust as a result of that. California, for example, has been under a state of emergency, which slows down the ability or reduces the ability of markets to change the price that they sell goods to you at, and as a result, they've been sluggish to respond. Okay, but when there aren't price controls in place, you typically have just as much as you want to buy of something as the sellers want to sell. Okay, so that's it for this video. The next 3 videos in this playlist all come from a documentary series called The Commanding Heights that goes into a little bit more detail about the history of these ideas and then how they played out. So the first of those next 3 videos talks about the situation immediately following World War I and the debate between free enterprise versus centrally planned economies. The second video picks up after World War II and talks about the case of West Germany and how the economy fared when they moved from a more centrally planned economy to a more free enterprise economy. And then the third video talks about the end of the Soviet Union and how that planned economy fell apart by the 1990s.